some reason my video shut off, so this is the end of 1.4. So what I was saying is that x minus 1 here, we know that x cannot equal 1, okay? So we got the answer x equals 1, which means there's no solution for this problem, okay? In other words, there's not a valid value for x. Okay, so let's go on ahead and do this next one. So we're going to factor first, so we get x minus 5 and x plus 5. And we're going to cancel our x minus 5s, and we get x plus 5 equals 14. Subtract 5 from each side, and we get x equals 9. So x cannot equal 5. Okay, so this is a good one. Let's go on ahead and do this last one. So negative 10 and positive 3 is going to be x plus 5 and x minus 2. Okay, over x minus 2 equals 7. Okay, those are going to cancel. So we get x plus 5 equals 7. Subtract 5 from both sides, and x equals 2. Well, if we look at that, we know that x cannot equal 2. Okay, so there's no solution here either. Okay. Alright, so that was the end of 1.4 because my video cut out. So let's go on ahead and move on to 1.5. So we're going to be adding and subtracting rational expressions. We're going to start out where they have the same denominator. Okay, so these are just, remember, these are just fractions. Okay, and if I have a fraction, if I have a fraction with the same denominator, I just add the numerators and the denominator stays the same. Okay, so let's go on ahead and do that. So here I have 3x minus 4 plus 2x plus 5, and my denominator is the same, so it's just going to stay the same. Okay, so now I'm going to have 3x plus 2x is 5x, negative 4 plus 5 is plus 1, and that's all going to be over x plus 3. Okay. The same thing here, you want to find out what can x not equal, so x cannot equal negative 3. Okay. Alright, let's go on ahead and take a look at the next one. So the next one is subtraction. This is the biggest mistake I see. Remember that when you subtract, you have to distribute that negative sign to both of the terms, or all of the terms in the second fraction. Okay, so we're going to have 2x minus 1, and then that's going to be a minus 4x, and that's going to be a minus 4. All over x plus 2. So that gives us 2x minus 4x is negative 2x, and negative 1 minus 4 is negative 5. And that's going to be all over x plus 2, where x cannot equal negative 2. Okay. So not too bad so far. And go on ahead and try these two on your own, and then we'll take a look at them. Okay. Alright, so hopefully you tried this. So x plus x is 2x. Negative 3 plus negative 2 is going to be negative 5 over x plus 4, and x cannot equal negative 4. Alright, and the last one, so 3x minus 6x. It's going to be negative 3x, and negative 4 minus 1, and remember, if this was a minus sign, it would become a plus, so you can't see that. If this was a minus sign, it would become a plus, but minus and a plus is a minus. So negative 4 minus 1 is negative 5, and we have x squared plus 1. So now, if we were to find out what x cannot equal, we have to set x squared plus 1 equal to 0. Okay, so that's going to be x squared equals negative 1, and we're going to take the square root of both sides. So in other words, x cannot equal I, an imaginary number, right? Okay. Alright, but we know from fractions that our denominators are not always the same. So when we don't have common denominators, what we want to do is we want to find the common denominator. And the easiest way to do that when we're working with polynomials and rational functions is just to multiply by whatever's not there. Okay, so let's take a look at these. So x minus 1 over this polynomial plus x over x plus 1. Okay, so the first thing we're going to do is we're going to factor. So here we're going to wind up with x plus 2 and x plus 1. Okay, so now I have these two fractions. X minus 1 over x plus 2 times x plus 1 plus x over x plus 1. Now remember, my denominators have to be exactly the same. So in order to make this one look exactly the same as this one, I need to have this x plus 2 here. And I'm multiplying by it. Okay, so whatever I do to the denominator, I have to do to the numerator. Okay, so now I'm going to go on ahead and I'm going to combine these things. So I have x minus 1 plus, I'm going to go on ahead and distribute this x squared plus 2x all over x plus 1 times x plus 2. Okay, so now I'm going to go on ahead and I'm going to combine my like terms. So I have x squared plus 3x minus 1 all over x plus 2 times x plus 1. Okay, I could try and factor this, so what multiplies to negative 1 and adds to positive 3? Nothing. Okay, so that's my final answer, and I know that x cannot equal negative 2 or negative 1. Okay, so that one wasn't too bad, right? So multiply by whatever's not there. Make them look exactly the same. Okay, so let's take a look at this next one. So for this next one, we're going to have x over x plus 3. We can't do anything with that. Minus 18 over, okay, I'm going to factor this x squared minus 9. It's difference of squares. So I get x minus 3 times x plus 3. Now I have to make them look exactly the same. Okay, so this one has an x minus 3 and an x plus 3. This one only has an x plus 3. So I have to make sure it has an x minus 3 there also. And whatever I do to the denominator, I have to do to the numerator. Okay, so now that's going to become x squared minus 3x minus 18, right, because of that minus sign, over x plus 3 times x minus 3. Now I'm going to factor if I can, so let's take a look and see if I can factor that. What multiplies to negative 18 and adds to negative 3? That would be x minus 6 and x plus 3. Okay, negative 3 times 6 is 8, negative 18. And negative 6 plus 3 is negative 3. Over x plus 3 times x minus 3. Now we're going to simplify, just like we always have in the past. So our final answer then is going to be x minus 6 over x minus 3, where x cannot equal, right, we're going to go back to this one, negative 3 or positive 3. So make the denominators look exactly the same. And let's go on ahead and do this one. So x minus 3 I can't factor, 2x I can't factor. This I can factor, and it factors down to x, let's see, plus 4 and x minus 1. And then this is x plus 4. Alright, so now here's my denominator for this one. Here's my denominator for my other one. What do I need to make these look exactly the same? Well, this one is missing an x minus 1. Alright, now we're going to go on ahead and do our addition. So we have x minus 3 plus, and you don't have to put parentheses around it, I just did because I wasn't thinking about not doing it, 2x squared minus 2x all over x plus 4 times x minus 1. Alright, so x combines with negative 2x. Okay, oh, well, let's start with this 2x squared here. So 2x squared, negative 2x and positive x is negative x, and then minus 3. All over x plus 4 times x minus 1. And now let's see if we can factor these things. Okay. So this would be negative 6x squared, which would be negative 1 and positive 6, or 1 and negative 6, 2 and negative 3, or negative 2 and 3, and the pair that adds to negative 1 is this. So now to have 2x squared minus 3x plus 2x minus 3, and I have to pull something out of each of these, so I'm going to pull an x out here, and that's going to leave me with 2x minus 3, and I have to pull something out here, so I'm going to pull a 1 out. That has to be 2x minus 3. So this is going to factor to x plus 1 and 2x minus 3 over x plus 4 times x minus 1. Okay, so those didn't equal the same thing, so nothing can cancel. Okay, you can either, some people will write the answers as polynomials, so multiplying these two binomials together. I don't really care which way they're written, but you do need to have in here that x cannot equal -4 or +1. Okay. Alright, let's see. I'm not sure if that's the end of these notes or not, so let's take a look. Oh, that is the end of those. So have a great day.